Just 1 more minute. Right, it looks like we're live on YouTube and Twitter as well, so I think this is a great time to get started.
All right, let's go.
Let's do it.
First of all, thank you for attending the second episode of our CTO office hour in the public. And last time we give a talk about the marketplace and demonstrate how to build a mini app. But this time around, we'll showcase how we successfully deliver a sponsored token claim to over 2 million users in mind. And I'm going to share a lot of good insights about this journey. This is a great experiment, uh, achieved by the Collab.Land team with help from a lot of friendly partners. So I'm going to just jump into that. Um, so first of all, I want to make a bold claim or, you know, token launch is very different from any traditional airdrop. So it's not the same old airdrop. So I want to highlight a few key points here. First of all, it's free for all the claimers. We cover the gas for all the claim transactions. So that's number one. Number two is the user just use a Web2 way to log into our system and qualify themselves and claim the token. So very much like, as a qualified user, you just log in with Discord, log in with Telegram, we check your qualifications, and we make the claim happen to deliver the token to the receiving address you gave to us. No wallet connection is required, no scary message signing is required. So really what we have in mind is to minimize the safety risk. There are a lot of scammers and features out there. So we want to make wagme.collab.land one single place and have this smooth journey. You just log in with Discord and Telegram to get your token. That's number two. Number three is it's really a very different skill because we aim to qualify more than 2 million users through our system. Uh, I believe this is a pretty good number comparing to a lot of traditional airdrops. Number four is we make a decision to really reserve some tokens for top 100 communities so that these early engaging communities, ecosystem will receive some funds, and these funds can help the ecosystem to do some good things altogether. So these 4 points actually differentiate us from a traditional airdrop. And from the technical point of view, to make it nice and smooth and safe, gave us very interesting challenges. But luckily, we were able to deal with all the different issues and have a reasonably smooth, token launch. We had a few hiccup at the beginning, but we were able to quickly fix those issues and scale the system to our expectations. And afterward, we didn't have any single disruption, and all the token claims went through very smoothly. And if you look at the transaction history, the token claims are still coming today. All right, so I made that claim, and I want to show some numbers so that it showcase the scale of this token claim. First, though, I took a database dump yesterday, and it shows like we have processed more than 134 user claims from our front end, from our API server. So that's pretty good. Then I really appreciate somebody from the community to build this dashboard, which can give you all the statistics in one place. Let me quickly launch that. So over the course of a little bit over 1 month, uh, we have about 58 million tokens being claimed. And this one, even though it says user claimed, I would imagine that's actually the number of holders we have in the smart contract. So it's smaller from the number I have because some users claim the token and now they kind of sold the token or exchange the token. So I believe this number is the current number of holders for the Collab.Land token. Then this is the average number of Collab.Land tokens. So this number is actually interesting because we paid all the gas for all the transactions. So far, we have, processed about 45,000 transactions on chain. So there are other numbers. I don't want to go through each of them, but these different numbers give you, a pick how many, transactions we process, how many users we serve, and how many gas we pay. Kind of going back to the slides, I just looked up the number yesterday. We paid almost like 30,000 US dollar worth of ETH for gases. And I built a bookmap and actually track all the different things here. So for example, if we look at the gas fee we pay, so we store a balance over 80,000 US dollar worth of E, and now it's about 55. Then, as you can tell, the claims are still coming at a slower pace at this point. So it's still ongoing. So that's all. Move to the next slide. So the first question from the technical point of view is like, hey, we decide to give tokens to our users and the community. Then who qualifies? How do we make that qualification into a knowledge base we can use, right? So we actually create three different buckets. One is the Patreon MP holders, and the second one is the membership MP holders. The third one is all users that at least connect one wallet with Collab.Land for one of the communities. So these three buckets are the qualifiers for this token launch. And interestingly, for these three different buckets, they have different nature. For example, for the NFT holders, right? We don't use the current owner address as the social choose. We basically use the token ID as a social choose because we understand on OpenSea, any marketplace, there could be transactions happen at any given time. So really, the snapshot only catch the number of token IDs we have from this NFT contract, and we check the token ID ownership whenever the claim happens. Then for the user side, we pretty much catch their Discord ID or Telegram ID as a social choose. So this qualification allows us to give our early adopters and supporters this retrospective, token drop. Then with the qualification rules in place, we need to take a snapshot. As I said, we took a snapshot based upon the three different slots, and we use different IDs for each of the qualifications, for the token IDs or for the user IDs. And we end up have more than 2 million user IDs that qualify for the Collab.Land tokens. So the next step, now we have the qualification. We dump all these qualified, identities into one CSV file. But how do we meaningfully ensure the integrity of the claim? Because when it comes to token claim, we need to have one single source of truth. And typically that will be something deployed in the smart contract, right? So we know this idea from past success of other token jobs and decide to use a merkle tree to capture the snapshot. Why? First of all, merkle tree is a very efficient way to catch the kind of like a ownership, right? So if you're part of the qualification group, then all your identities will be part of that tree, and we end up build a hash all the way to the root. and that root hash has the ability to verify if you are part of that tree or you are not part of the tree. So that's a very meaningful way to support this many qualifications in a smart contract. Right? So that's really the to choose in a smart contract. Second one is we can freeze the qualifications and speed the lookup. Right? So when a user coming to our front UI, they're logging with Discord or Telegram, then we just have to look up the patron NFT, membership NFT ownership to retrieve the corresponding token IDs, and then look at the community perspective to retrieve the user ID. Then we can pretty much just quickly look up from the tree what different slots that user will qualify. So that's number two. Number three is with the Merkle tree, we have one single social truth in a smart contract. That means we will have the security, the confidence. If something went wrong in our front end, in our back end, it's not going to be mess up the final qualification, and we always have the ability to recover. So this decision allows us to retry, meaning if a user failed to claim, for some reason, either it's a bug in the software or some other issues, the user can always retry and claim the token they're actually qualified for, right? And even for some users, they might have multiple qualifications, and these multiple qualifications can come in from different wallet addresses. Uh, so say you own a patron NFT in one address and you own a membership NFT in another address. So this Merkle tree approach allows people to claim independently. Say if you qualify for 5 different slots, you can claim the first 2 slots in one transaction. You can claim the rest of 3 slots in another transaction. So that's the beauty of the Merkle tree based approach. So I talk a little about how, so when you build a Merkle tree, right? So you need to come up this idea what exactly a leaf would look like, right? So we have 3 types of leaves. One is a patron NFT qualification. Second one is membership NFT qualification. The other one is community user ID qualification. Then we build this leaf in such a way. First, though, we have a key, and the key would be the patron NFT token ID, or the membership NFT token ID, or the community user ID. Then the value will be the qualified amount of Collab.Land tokens that slot will entitle the users to claim. So I want to share one fun factor here. So we end up building a Merkle tree with more than 2 million lists. And guess how many minutes it will take for our backend server to build that Merkle tree from ground zero. So it actually took 5 minutes to create that tree in memory and block everything because it's a CPU intensive work. So we have to deploy a separate pool of token getting API server and pre-warm the server so that whenever it's ready to serve the claim request, this Merkle tree is available in memory, after 5 minutes. Right. So that's the Merkle tree idea. Then once we have the Merkle tree, uh, we want to deploy a token distributed smart contract for the token distribution itself. As I said, we learned from the past success of this, airdrops, and this project came into our mind, which is the Uniswap Merkle tree based distributor. Um, it's a pretty nice project, but we have to do some surgery for this smart contract to support our use cases. Why it's different? So there are a few assumptions from the Uniswap contract. First of all, they know all the recipient wallet addresses ahead of time, but we don't have that luxury because our claim flow allows every single user to give us a recipient wallet address uh, when the claim happens. So that creates a little chicken egg issue, right? So we cannot uh, we use a different approach for the user to claim the token because we sponsor the transaction by paying the gas fee. So that means the users don't really submit a transaction with their wallet, because the assumption from the Merkle distributor from Uniswap is really the uh, wallet that sends a transaction will be the user that claims the token. So they can use this message of sender and use that as a social truth to go against the Merkle tree they have as the recipient wallet address for the lifts, right? But we don't have that either. Uh, Number three is since we don't have that message of sender luxury, and we have kind of like a bundler or executor from Collab.Land, and that wallet it's actually sending all the transactions to our smart contract. But theoretically speaking, we design the system in such a way, once we have a signed request for a given user claim, it doesn't matter who submit that transaction, right? So whoever is willing to pay the gas, they can submit the claim transaction on behalf of the user, because in our design, the social truth is coming from the Merkle tree, and to verify you have a fair share in that Merkle tree, Merkle tree have this single proof or multiple proof concept that can meaningfully verify you are part of that Merkle tree and how much qualifications you have. Then we have utilize this permit pattern, which basically is a signature by the authorizer wallet of chain, and we sign the request that includes the amount, include the proof, and even include a TTL. Say we specify 1 hour, that means the signature can only be used to claim the token within that 1 hour, right? So that's number three. Number four is when we deploy the smart contract, it need to receive the budget for all the token allocations, or so-called like allowance, right? So we don't want to have the distributed token contract to own this balance. So what we end up doing is we have a multi-sig wallet that functions as approver, and that approver um, approves certain budget to the Merkle tree, you know, uh, distributor, and that Merkle tree distributor smart contract will use a transfer from the approver, which is our multi-sig wallet, to transfer the qualified token to any given recipient wallet address for any claims. So that's the smart contract side. And of course, you can look up the contract source code from the smart contract address. I have that on the site as well. So let's go to that. So remember, we try to cover the transaction gas for all the claims. So that has to be optimal, right? So we make a couple of decisions here to support that. First, though, instead of having the token claims directly happen on Ethereum mainnet, which is a pretty expensive, and the confirmation time is quite long, so we decided to use L2, which is optimum for the token distribution itself, right? Then when we do the final testing, we were running this transaction fee issue. Uh, so there's a so-called magic L1 data fee, because Optimism has roll up to the Ethereum mainnet, right? So some of the state happening on Optimism will end up showing up in the Ethereum mainnet itself. So that actually becomes the major cost for every single transaction. Uh, so I can probably show one transaction, and you can look at that just from the live smart contract perspective. So let's say we pick this transaction. And if we look at here, so this transaction costs us almost like more than $2, right? But if you see the breakdown, this is so-called L1 gas. So this L1 gas price is the majority of the cost for that given transaction, because uh, the optimum side is basically the execution layer, right? So the transaction is executed on L2, with the data replication to the ECM mainnet, we end up have to pay the L1 gas. So that will becomes majority of the cost we have. So initially, we look at the possibility to cut down the cost for the the different bytes we sent to the transaction, right? So if we look at that a little bit as well, so we have this distributed contract. If you look at the contract, and there's certain data structure in that contract, and we end up have to do some optimization to that, a lot of stuff here. Yeah. So this is the one, right? So we have this so-called like a claim request, structure, and we end up have to fine tune the different byte size. So for example, instead of use the default one, we use a smaller one, which is on-site index 24, and we did some calculation. Oh, this number of indexes will allow 16-minute lifts, which is good enough because we only have a little bit more than 2 minutes. Since then, for this amount, because we know for every single claim, a one single slot won't go over like 1.2 million tokens. So we choose to use 80, right? So those are the different minor optimizations we did to cut down the cost, but that didn't help too much because of the L1 data fee, right? So we end up have to introduce this simpler claim request, because as I show in the slide, we have two different kind of qualifications. One is the NFT ownership based qualification, because that gives much more tokens to the qualifiers. Then the community based claim usually just give 10 Collab.Land tokens per user. So we decide to have two passes. One is for the traditional NFT based token claim, and we have a stronger security and stronger proof for that. And the second one is so-called like a simple claim, and we kind of go back to the traditional wisdom for the blockchain transaction and only verify the message sender for that purpose. So that cuts down the cost to something that don't put us into a path to burn a lot of gas from this sponsorship. Right. Uh, so that's the optimization we did to achieve our goal. Like we basically have two different paths. One is a heavy path, which is much more secure but much more expensive. The simple path is still secure enough, and we have the confidence, but a minimize the gas fees. Then we also, optimize the smart contract execution. Instead of claiming the slots one by one, we create this batch flavor so that we can bundle multiple claims in one transaction, which will save our gas as well. Okay, so that's that. Let's just move on to the next one. All right. Now we have the social truths as the token distributor on Optimism, right? Then kind of going back to the very basics, where is the Collab.Land token smart contract? So we decide to have this multi-chain support. We use the Ethereum mainnet as a root for our ERC20 because Ethereum mainnet is the most reliable and secure blockchain. A lot of value happen there. So we decide to use that as a root of our multi-chain story. And we deploy a ERC20 contract on Ethereum mainnet, right? Then to allow the token distribution happen on L2, also along with the requirement to extend the smart contract with store functionality there. so that we can meaningfully run a DAO, use the optimum token ownership as a social choose. So basically, we deploy two smart contracts. One is on Ethereum mainnet. The second one is on Optimum mainnet. And then as you can tell here, the two smart contract ends up have the same token address because that's a really nice to have feature. We want to make sure we do all the work and avoid any confusion for our users. So we use the counterfactual deployment so that we get the same contract address on both chains. And what's interesting is this approach also give us the flexibility. We can actually, expand our token ecosystem onto other, side chains or L2s. For example, the Ethereum mainnet could have a corresponding branch to Polygon, to Arbitrum, to even some of the ZK chains we have, right? And what I observed from our mainnet smart contracts, one user actually break the token from Optimism back to Ethereum mainnet. So that means in the future, if we have a token claim happen on another L2, we can do that because the token supply can go from Optimum back to Ethereum mainnet. Then from the Ethereum mainnet, we can go to another chain. Right? So in total, we have 1 billion times that token mainnet on Ethereum mainnet, and that amount of supply was immediately bridged to Optimum, to our multi-sig wallet. It's a no-safe based wallet. Then, as I said in the past, the multi-sig wallet function as an approver to our token distributed contract, and it just approves the allowance to our token distributed contract to do the claim processing, right? But theoretically speaking, the multi-sig wallet still owns all the tokens, and it just gives the token distributed contract the budget to do the token claim. And at any point, we can, remove that allowance so that the multi-sig wallet will stay as a social choose in a very rare situation, or we actually finish the cycle for the token claim, which are coming in 2 months, right? So another technical challenge coming because we want to sponsor all the transactions, right? So that means from the transaction perspective, there's going to be one single sender or at the most a couple senders from the pool, right? So that means we are going to use one single wallet to execute many transactions concurrently. So if you are familiar with how Ethereum transactions are processed on the blockchain, there's one important factor, which is the sequence, right? Because you want to make sure the transaction come in sequence so that the state could be updated by the blockchain in a meaningful fashion. So that creates a huge challenge for this approach because we have one single wallet address on that particular blockchain. Then we need to deal with so many concurrent transactions. We cannot afford, running the transaction one by one because we have so many user claims coming, right? So we end up creating this interesting approach. I did a lot of research on the internet, and the closest one is from MetaMask. But MetaMask makes the assumption all the concurrent transaction coming from, you know, uh, just a couple front end, right? But our scale is very different. We're running multiple server instances to do the claim behind a load balancer. We have multiple processes that utilize the same wallet to submit transactions, right? So this traditional approach work well. So we end up build a Redis based approach, and this diagram kind of illustrate that idea. So for any wallet address, we maintain a sort set from Redis, and this sort set maintains all the available nonces we can claim to submit a transaction. Then from the application code perspective, it does two things. One is to acquire available nonce from this sort set. And second one is if the transaction failed to submit, we need to return that nonce back to the sort set. Because if we create a gap, in that system, then all the other transactions with high nonce will be stuck there. So we need to have a meaningful way to return that nonce back to the pool so that the next claim will pick that up and unblock everything else. Another interesting is how do we sync up between the blockchain and our Redis solder set, right? So we use this cursor, say, hey, from the blockchain, you can get a current transaction count, and that serves as a separator because any nonsense below that value need to be thrown away, right? Because when we reach a transaction counter, that means all the nonce below that value has already been part of the pool for processing. Right. So there, another interesting question is because if we maintain this sort of set, how many availability we should have? So we don't have to put all the available nonce in this sort of set. So we have one algorithm to check the availability. If we end up only have one left, then we keep adding, 100 additional to that sort of set. So that get automatically refilled on demand. So this is how we actually, use the Redis as a like the coordination layer, and we have to use a Lua script so that all the Redis operation will happen automatically. Right, so that's a key requirement to coordinate this distributed loss management. Then when it comes to the token claim process, we use multiple tiers to track the claim status because sure, the social truth is in a smart contract. So we can always allow the user to go through and have the smart contract to be the gatekeeper, right? But the one downside for that is it's wasting gas fees, and we are paying the gas fees. So we want to fail fast, right? But from the security perspective, the token distributed contract will always have that, authority, right? And we maintain the state for the different claim for the different slots. So there's no way for somebody to double claim. Right? But to make it fail fast, we also maintain database records, Redis records, so that we know where a user coming. First, though, we minimize the window for user to claim from two different browsers at the same time. Right? Even though that will fail ultimately in a small contract, we don't want to waste that gas and create a DDoS, vector. So we use Redis to control the concurrency to make sure the user have no chance to submit the same claim from two browsers at the same time. Then we also maintain a database record to understand the different phases of the token claim. One is requested, that means it's coming from the API server, from the front end. Then we have this claim status, then we have this field status. So for the field status, then we make that eligible for retry. Okay. So toward the end, we also have the ability to use the on-chain state to reconcile the DB records. So the on-chain state is a final state. If we have a bug or we mess up with the DB record, we can always recover from that. Another technique we use is use a queuing system. So remember we talked about how we optimize the claims and try to bundle as many claims in a meaningful way into transactions, right? So we end up building two different queues to take token claim requests from our UI API. One is a regular claim. The second one is a simple claim. Okay? So this way, we define a time window. Say, hey, we wait for 1 minute, and within that 1 minute, all the claims coming to that 1 minute, either the number of token claims in this batch, it's kind of reaching the limit, or the time is reaching the limit. Then we have these two dimensions to control how we bundle claims into transaction for on-chain. Okay? So that's so the queue actually serve that purpose really well. And also it provides an auto recovery capability because as I mentioned, like we had a few hiccups at the beginning. We underestimate the passion from the community to claim the token in the first hour. Then our system has to recover from that a little bit. Then of course, one good thing is all the pending claims still queued up in the queue. So when the system recovers, we can pick up all these requests and process that in the backend without the user to retry explicitly on their side. So the queue give us that nice, buffering and the recovery capability. Uh, and I want to share a few interesting facts as well. Again, we underestimate some of the extreme cases. Right? So say some users actually owns hundreds of NFTs that end up exceed the boundary of one transaction data requirement. It's just too heavy. Right? Say if you have 100 NFTs, then we end up have to build, you know, the multi-proof from the Merkle tree to contain that 100 slots. Then together with the signature and the timestamp, then of course that amount of input data cannot be handled by the blockchain. So we end up having to do divide and conquer. So meaning for these, heavy users, we have to break down their ownership into smaller batches. Then we end up, submit multiple transactions for these, heavy users to claim that tokens. So that's another technical, workaround we have to do there. I talk a lot, and I talk about a lot of different pieces, but this diagram kind of give you the overall picture, right? So I want to start from the back end on the smart contract side. So the purpose is to claim this Collab.Land token, right? And as I said, we have this multi-chain support, and we have two smart contracts, one from the Ethereum mainnet, which deposit the tokens into the Optimism side. Then, of course, there's a possibility to restore the token from Optimism side back to the Ethereum mainnet. Then the Optimism, token contract is the supplier for all the token claims. Then we have this Collab.Land multi-sig wallet controls the budget and giving allowance to the Merkle tree-based distributor. And the Merkle tree-based distributor stores a root hash coming from this qualification Merkle tree. And as I said, we transform every single qualification slot, like the token IDs for patron, for member, for community. Then we end up build this gigantic Merkle tree that takes 5 minutes to build everything up in memory. Then this Merkle tree was built from the snapshot, and we took that snapshot and stored that as a CSV into our S3 bucket. Then the snapshot is based upon the decision, like patron NFT, membership NFT, and some other member-based qualification, right? Then of course, going back to the decision-making process, like we decide what are the qualification rules we have, for each, slot, how many tokens would they qualify. So that's from the product side. Then as a user, you go to wagme.collab.land site and you log in with Discord, Telegram. Then with that authentication, we can quickly look up from this Merkle tree and figure out, do you qualify for certain claims? And once you have that matching, then we also check the smart contract status in addition to the database records to say, even though you qualify for these 3 slots, but these 2 slots are gone, it's already claimed, so that you end up can qualify for this 1 slot for this claim, right? Then depending on the different nature of the claim, we have simple claim and regular claim. For the regular claim, it's pretty heavy, so we pretty much utilize the security model from the Merkle tree and create a multi-proof and with off-chain signature. Then we use this a Collab.Land signer wallet to submit that claim or claim batch transaction to, and we kind of mentioned to manage that concurrency, we have to introduce a distributed nonce management tool from our Redis capability. Right? So this is a very busy picture. So I kind of dump a lot of information, and this is kind of at the slide. So definitely giving this insight for you, it's really showcase like how we did this meaningful experiment with our users' interest or with our community's interest as the first priority. And we care about the usability, we care about the safety, we care about how users don't have to pay a dime to claim their qualified tokens, right? Uh, so we further open up the door for the platform so that we can meaningfully allow all the builders to come into our ecosystem to meet the demand of our tokenized communities and users. So we launched the marketplace and we start to build up a lot of mini apps and definitely encourage all the developers, you know, come on board to be part of this fun journey to create a lot of meaningful features or utilities to the Collab.Land token, to our community, to our users. So I give a few pointers here so that you can talk to us, you can try the different templates and the examples we have, and have your valuable Web3 project in front of thousands of tokenized communities and millions of users. We are happily serving and being trusted by them. Right? So this is the end of the slides, but I want to leave some time for Q&A. Let's see if there's any questions I can take. TB, do you see any questions or you want to invite anybody to the stage? TB, are you there?
Chibi's saying I think her mic is not working. Maybe Amen. Yeah, give her a second. I think we don't have any other question now.
I'm sorry, I feel like my mic stopped working, but can you hear me now?
Yeah, I can hear you now.
Awesome. Yeah, I don't see any questions right now, but if anyone has any questions, please feel free to raise your hand or you can write it in the stage channel or in the dev general, and we'll make sure to bring those up for Raymond to answer. In the meantime, would this be a good time, Raymond, to distribute the POAP for today's call? What do you think?
Sure. Yeah,
Yes?
that's a good idea.
Awesome. All
Should
right.
I stop screaming?
We can do that. I think so.
Okay.
All right, everyone. Again, thank you for joining. And if you are all ready, I will guide you through the process to claim this POAP using our POAP mini app. So that's exciting. And if you haven't used it yet, be ready because we will guide you through the steps. So for this distribution, again, we're using the POAP mini app, so you don't need to have the POAP app installed in any of your devices. It's all going to be through Discord, and this is going to be through a slash command. So in order to claim your POAP, you will write in any of the chats of the server. You can do it in the stage chat if that's what you're using right now. You can write slash, then you're going to write POAP, and then you should see a drop down with some options. You can either select POAP claim or you can write it down slash POAP claim, and then you will see a little box with the word claim phrase. And what you're going to write inside that little box is small contract. Sorry, smart contract. That's the secret word to claim the POAP. It's all lowercase, there's no spaces. Smart contract. And then you're going to hit send, and you should be able to claim your POAP that way. You will receive a link for you to use to claim the POAP. Please, everyone, give it a try and let me know if it's working. Again, the secret word is smart contract. All
Yeah,
lowercase,
I
no
was
spaces.
able to claim it.
Yay! Awesome. It worked for GC as well. Thank you, GC. Let's repeat it once more just in case. Oh, yay. So again, this is a slash command. So you need to write down slash POAP claim. And then the claim phrase is smart contract.
And as you can tell, what we are striving to do here is really break down the barrier to end Web3. So we built the user experience, we built the different utilities, and then we built the mini apps to make your life easier. So I think the pop mini app is a good showcase to that journey.
Absolutely. I feel like it's so easy to do everything within Discord, not having to go to a different app and do the human verification game. That's just so difficult.
Somebody missed the game. They want to do that.
Oh my god. I mean, you get used to it after a couple of tries, but I remember the first time trying it, it was it was just too much. I gave it like 3 tries to get it right. But yeah, this is much easier, which I'm thankful for. And yeah, this is what we're going to be using for future POAP distributions when it comes to our Discord events. So I think it's nice to to learn how to use it. And it looks like people are claiming successfully. So that's always exciting. Oh, I see one person has said lowercase not working. Again, it's 2 words, but there's no spaces between those words. Smart contract. A lowercase and no spaces. Please let us know if it works.
So the slash pop link command produce a link, and you probably have to click on the link to launch a website. Then you can get your pop into your wallet.
Yeah, I also just posted a screenshot of the slash command. So in order to claim your POAPs, you use slash POAP claim and then enter the claim phrase. That's smart contract. Those 2 words together with no spaces in between and all lowercase. Oh, thanks, Oops. We love POAP, that's true.
So while we are having fun with pop, also ask from my side, I would like to cover as many topics as possible, but your feedback will definitely valuable to our exercise. Like we probably would love to hear your opinions. Even you have any special ask to um, have different content or different topics, definitely welcome to provide feedback uh, on our Discord channels or any other channels we have, and we will customize our sessions to meet your needs and give you more technical insights as we are going through this interesting journey that expose us to many different aspects of the blockchain. We try to be a good bridge between Web 2 and Web 3 and really always put our community and the users priority as our first priority. Feedbacks are really valuable to make us do even better.
Yeah, absolutely. Please, everyone, feel free to share your feedback, comments, questions with us because they're just super important for us. And yeah, that's how we build together and how we grow together. So we're really thankful for that. Jay, I see that the people that were asking for the word again were able to claim successfully. So yay for that. And yeah, I'm not seeing any other questions right now. So I think that we're ready to wrap things up. What do you think, Raymond?
Yeah, I think that's a good idea to give a couple of minutes back to the audience. Again, thank you for attending this second episode of the City of Venezuela, and I'll probably see you in 2 weeks.
Yes, we'll make sure to let you guys know in the events channel um, about the next CTL office hours. That again, as Raymond said, is going to be in 2 weeks. But yeah, stay tuned to those if you would like to set your reminders. We would love to have you here again. And yeah, thanks everyone for joining. And thank you, Raymond, for this awesome session.
Yeah, thank you, Chibi, for make it happen.
Oh, of course. See you guys next time. Thank you.
Bye.
Bye bye.